This is Preview Video 2.2, Part 1, Segments on a Coordinate Plane. Take a minute, sit tall, chin up, inhale, hold your breath, taking a look here, you're in your preview notes. Don't forget a parent or guardian sign off, as well as date, time, location. I'm going to be talking about segments on a coordinate plane. Segments on a coordinate plane. Keywords here would include rise, run, slope, something called midpoint, distance, and average. Coordinate planes are used in a variety of professional settings. Archaeologists use them in grid systems, creating physical grid systems for discovery. Different kinds of engineering and map and GPS systems use grid systems for location. So learning how to orient segments on a grid system, both 2D and 3D, is really significant. So archaeology, simulations, different kinds of grid system simulations, and cartography. There's three skills you have to be able to do with a segment on a coordinate plane. And when I'm talking about a coordinate plane, I'm talking about an XY horizontal vertical grid, XY. In future math classes, we'll go into a 3D, where like physics, as well as trig and calculus, 3D, we add a front-back depth grid called Z. But for our use and purposes, we're going to stick simply with the horizontal, vertical, two-dimensional grid system. On this grid system, you need to be able to find the middle of a segment on a plane, the tilt of a segment on a plane, and the length of a segment on a plane. The middle, the tilt, and the length. First, we're going to talk about notations. S is at -8, and T is at +2. We're going to find the exact middle and plot M, the exact middle between these two. And you can see that the distance here is 10 units, or 10 bunny hops. So the exact middle. 5 bunny hops this way, 5 bunny hops that way. Our exact middle is -3. So that's one way to find the middle, is to simply physically bunny hop on a number line. However, there's a bit faster here. Our point S is at -8, and our point T is at +2. So if we average, which is add and divide by 2, we get -3. So the average of two coordinates is also the coordinate of the midpoint on a number line. Now, a number line is only one dimension. That means it's just length. So to find the middle between S and T, we only had to average once. But a grid or a plane is two dimensions. So to find the midpoint on a grid, you have to average twice. I'm going to give you a little technique to memorize in a moment. To memorize the midpoint equation, what you need to do, you're going to say and write the equation. We're going to use what's called a blank template, and we're going to do circle, plug, chug. So for now, we're going to say and write the equation, midpoint equation, 3 times. And the midpoint equation is add the x's, divide by 2, comma, add the y's. Divide by 2. You're going to say it and write it 3 times, just like that. Ready? The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. Now we're going to use the midpoint equation. We're going to follow these steps. We say the equation. We write a blank template and we circle, box, plug, chug. I'll explain what this is. First, we're going to graph these 2 points. -5, +3 is right here. And 1 and 5 is right here. Our template is a blank equation minus the x and y's. So the midpoint equation is we add the x's, divide by 2, add the y's, divide by 2. Notice I left the spot for x and y blank. That's called a template. Now, we circle the x's and plunk them in. Circle the x's and plunk them in. Box the y's. Plunk them in. Notice you go the same direction each time. That's really important. I went top, bottom, or kind of left to right. Either way, you must be consistent in the direction you go here. Now we're going to graph that midpoint, which is -2, -1. When you graph it, you can see, what's really nice about this is you can see that it is the physical middle. Ready? You're going to do this page, that section, on your own. Alrighty, welcome back. Let's see how you did. You should have gotten -2, +6.5 as the midpoint here after graphing the points. It's very important you graph the points. So let's go ahead and plot that. That's -2 and then 6.5. So we go up 1, 2, 3, 4, 5, 6.5. There is our midpoint right there, -2, 6.5. Don't be afraid of fractions on a graph. All right, so that was finding the middle of a segment. The next thing you need to be able to do is find the tilt of a segment. And tilt is what we commonly call the slope formula, the tilt. So we're going to say the equation and write the equation. Rise over run. Here's what you're going to say, and we're going to say and write 3 times. Slope is rise over run, subtract the y's, over, subtract the x's. Let's say and write at the same time. Slope is rise over run, subtract the y's, over, subtract the x's. Slope is rise over 1, subtract the y's, over, subtract the x's. Slope is rise over run, subtract the y's, over, subtract the x's. Now, most of you probably memorized this originally as y2 minus y1 over x2 over x1. Let me explain why I don't use that technicality, because it really doesn't matter which one is point 1 and 2. Let me demonstrate for you. Here's our same 2 points. We have -5, 3 right here, and 1, -5. We're going to do this twice. So here's your template. Your template, very, very super duper critical that you always do a blank template first. Then you circle, plug, chug. Let me show you why first and second point doesn't matter. The y's go on top. So for the first time, I'm going to go left to right. Y's on top, X is down below. Notice I'm physically drawing arrows. That's kind of important. It keeps your brain from switching directions. As long as you're consistent in your directions, you'll get this correct. Now we're going to do it again, right? The same 2 points down here. Now we're going to switch our direction. So we're going to go from the right to the left. Right to left. Okay, let's check our work here. Our slope is, for this, that is going to be -2 over -6. Which is +1 over 3. This is going to be Caught my mistake in my drawing here. This was a -5. -5. My pen went over that. So that's going to make this right here. That is 8 over -6, which makes this -4 over 3. And this is going to be -8 over positive 6, which is still negative 4 over 3. So you can see no matter the direction you go, you're going to end up with the same slope. So to here, to be consistent, start left to right, finish left to right, go right to left, finish right to left. Choose one. This page you're going to do on your own. Pause the video and restart. Alrighty, you should have gotten 3 over negative 2 or negative 3 over 2 either way. And you can double check this. Our rise is 3 and our run is 2. And that's a negative tilting line. So negative, rise is 3, run in 2. So that's the slope confirmation physically on the graph.